All right. Craig, we failed the intro.
No, we didn't. We got it right.
Yeah. I turned on. Yeah, we got it right, but I turned it on the preview and listened to the volume, and it started out with me going, "Okay, so 12 seconds after I say mute me, mute me." This is fucking. This is the best shit ever, man. I love it. I love the live fuck ups.
Yeah.
All right, so I'll turn it over to you since you're hosting tonight.
Oh, welcome everybody to Team Skeptic's channel. Tonight I will be moderating a discussion between Team Skeptic and Concave Earther Zenith Atlas. I spoke to Zenith a few days ago. It was actually a pretty good conversation. I enjoyed it very much. There's a lot of things that didn't get covered, and I hope that Team and Josh can cover what was missed. So what we're going to do is, to start, we're going to let Josh have 10 minutes just to give us some evidence of what he thinks the shape of the Earth is, and then we'll go over to Team, and then there would just be a moderated discussion between the two. But before we get started, Zenith Atlas, Josh, how are you doing today?
I'm doing well. Thanks for hosting.
No worries. Thank you for joining again. So why don't we just get this started, and you can start presenting your evidence. I'll give you 10 minutes.
All right. I'm getting a bit of an echo from you. I don't know if anybody else is as well. If it's just me, that's fine. We can continue.
I don't hear an echo. I don't.
Okay. All right. Cool.
Okay. Right. So if you want to...
Yeah, I hear an echo too, fight.
Oh, that might be my headset again. I'll turn my headset down.
Maybe... Does everybody have the Hangout call muted? Their mic hanging out.
You know what? I didn't have it muted, so that was probably me.
There you go. It's better now. All right, so we're good.
Yeah. Okay, so whenever you're ready, just present what you want to present.
All right, cool. Well, first, I'll give a brief introduction. My name is Joshua James Bolliero. I started researching cosmology, 2015, looking at flat Earth and looking at, the evidence, presented, the downwards curvature of water, everything NASA shows us, stuff like that. So I entertained flat Earth for a little while, and it just, it obviously has lots of problems, the maps, the seasons, lots of, quote unquote gravity, stuff like that. So upon further investigation, I got my own camera and I started doing a lot of filming and looking at, how far we can see and how far, refraction should allow us to see. And I just, it's, when you look at the Skunk Bay time-lapse footage, you can see, our view of everything is being altered by the air. There's no argument there. Based on my experience, my observations, I think there's some misunderstandings about how light refraction is affecting how we see over water. And I do think there's a curvature to a spherical Earth, and I think that curvature is upward rather than downward. But clearly I've moved away from the flat Earth position because it doesn't have any substance. It doesn't have any tangible, measurable evidence. The distances, there's no measurable flatness of water. No, all the laser experiments, they do 2 measurement points. We need at least a third measurement point in the middle to ascertain, whether it's flat, curving up, curving down, whatever. So with that being said, I guess if I have the screen share up, I guess I'll just go to my channel and show, I have compiled evidence in the manner of different playlists, including this one. This is obviously observable evidence is very important, and the Cell Earth evidence playlist is here. Wait a minute, where did it go? Oh, it's here somewhere. Here we go. This evidence playlist here.
Hey Zenith, can you do me a favor? Can you do me a favor and turn down your music just a bit? Because I'm having I want to make sure that I hear everything, and I'm having trouble hearing it a little bit.
I actually can't in the background, so I'll try to cover it up a little bit.
Okay.
So, is that better? Are you hearing it better?
That's fine. I'll deal with it. Not a problem.
Okay, so the first thing I want to share is I'll just play this one piece of footage here, and I just want to show. Okay, I don't know if I should mute this or probably should. So I'll just let it play and it'll load. Okay, so I've got the camera very low to the water, where the refractive index would be the highest. I understand that. But I don't think that keeping our cameras on the tripods at 4 or 5 feet altitude is really going to do much, because then you get that whole hallway perspective argument. Oops. So here you can clearly see that the shoreline is clearly above, above that boat. And if, here we see an example of how a distant object is higher, at a higher elevation. Now this boat and the people on it have to be several feet high, and my camera is only a couple inches, which means that to be looking over any of these boats, I must be looking upwards. Okay, so I have to be looking upward from 5 inches to see over these people's heads. They're about 8 feet. If this boat, fishing boat's only 2 feet off the water. Okay, so we have to be looking upward, and yet we're still seeing the shoreline above all these boats looking upwards. We know we're looking upwards over these boats, and we're still seeing this. So I just, and that cargo ship, this is Lake St. Clair in Michigan. Okay, that cargo ship, that red one that you saw there, that is about 10 miles out. This travels from north to south and south, and I'm looking eastward. I'm looking eastward across Lake St. Clair, and those cargo ships run north to south, and they're a good distance away. This cargo ship here. So we have observable upwards curvature. Now we can argue about light refraction and whether we are, as Rob Skiba said, I think we're seeing it because it's there, and I would agree. And I understand all the magnification, lensing, looming. I studied that when I was trying to disprove the downwards curvature, and I believe that I can. However, what I can't do is prove any flatness to the Earth. So that's some observable evidence that I just want to show real quick. And there's different things that I know there's going to be a lot of flat earthers in this audience, and so that's why I think this evidence right here is very important, because there's experiments in here. There's experiments in here that show water does bend. So I'm with you guys, Fight and Skeptic. Water does bend. Here you go, flat earthers. Water bends. It's diamagnetic. It's curving up or curving down. You're going to have to accept it one way or the other. This, just using lens, we can bend light. We can bend light to the point where we can mask objects. You can see right through stuff. Cloakability, if you will. Here you go, bending light. So this playlist in here is really mainly geared towards helping. There's two types of flat earthers. One is a flat earth promoter that knows the earth isn't flat, and two, the genuine person who is duped and believes the earth is flat because water always finds its level. So this, observing water with a curve. Okay, so here's a lot of observable. A lot of these are experiments showing, levitation, diamagnetic levitation. We can rotate a levitating sphere. That is possible. I just don't believe we live on a rotating Earth. I do believe there is a rotating celestial sphere to a stationary Earth, and that rotating celestial sphere contains the emitting quote-unquote gravity, and so that's why we're detecting 15 degrees to the gyro. The argument exists between heliocentricity and flat Earth, and I truly believe it's a false dichotomy, and I believe that concave Earth has a lot of answers there, because we could have rotating gravity. See, in the heliocentric model, gravity rotates with the Earth, so there's nothing stationary relative. But in the flat, in a lot of stationary Earth models, you've got to have a stationary gravitate. We're just going to use that term, gravitational forces. Okay, we could go on and on about terms, but in the concave model, you can have a stationary Earth and you can still have your rotating gravity. So it's really something to consider, And then I posted to Facebook a video that someone created, talking about the LIGO and whether or not there is or isn't an ether. I wasn't able to see any strong evidence that there's proof of convexity of water with the LIGO. But I do think it's an interesting thing that everyone pay attention to. So with that being said, there's a spherical model of the Earth that is contained, that is stationary. We do have a working. Actually, there's hundreds of ancient maps. There's a Pinterest link Cass Kring created that's got over 700 concave Earth maps from history. Now, Flat Earth land doesn't have any ancient maps. They've got paintings. They don't have working maps. They've got time calculators. They don't have working maps. They can't produce a functioning flat plane, whether it be square, rectangle, circle. I don't believe NASA can show real images of an entire sphere Earth from a great distance away from the Earth, as they claim. I do believe that this rotating sphere I'm seeing right down here, and I do believe that that CGI ball Earth that I'm looking at over here, and that CGI azimuthal equidistant, I do believe all of those are incorrect. And I don't necessarily believe that the standard LSC model of concave Earth is 100% correct either.
60 seconds left.
I do believe that's a stepping stone. I do believe all these models are stepping stones. I don't think any one person has the truth, and so that's why we're here, so that we can all brainstorm, share ideas, learn from each other, and hopefully help out a few flat earthers in the process.
Okay.
So that's it. I'll kick over the floor to you guys.
Thank you very much, Josh. I do appreciate the evidence to look at. Team, do you want to take 10 minutes just to show any evidence you have of the Earth not being concave?
Okay.
Or whatever you want to.
I'm sorry. Again, I thought I was just. I thought I was just addressing his points because we can both agree that there's some kind of curve to the shape of to the surface of the Earth. I have the scientific consensus at my back, so I'm going to not take the approach that the Earth is a globe. I'm actually just going to come at you as a concave skeptic. So I'm going to be skeptical of the model that you present tonight. Are you okay with that? Okay, good deal. All right, and I'm sorry, that's what I thought we were doing, fight.
No, that's cool.
All right, so you said that things in the distance appear above smaller objects that are closer. This again, and I hate to I hate to keep using the word refraction, but because you have to, simply because of the fact that any kind of visual observation you make is a dynamic observation. Okay, it's not cut and dry. There are, in any kind of law that will describe what's going to happen is going to be an ideal law, which means it's going to be under ideal circumstances. We can't guarantee that the atmosphere is going to produce the ideal circumstance that we want to have, nor can we use it to produce like a good model of what we should be seeing. This is why the control points that I brought up with JM Truth were so important, because when you use surveying control points, you can kind of get a generalization of what you should and should not be seeing. So in the case that you're showing me here, you're telling me, and this is what I'm getting from it, is that for you to replicate these observations, you have to move the camera closer to the water. By moving the camera closer to the water, you're going to change the refractive index from what it would have been had it been 1 meter up would have been at 2 meters up, at 3 meters up, at 4 meters up. So my suggestion, if you want to provide a compelling piece of observational evidence, it needs to be taken from different angles. You can't just use the one that matches your pre-drawn conclusion. You have to also see if your same pre-drawn conclusion matches at 1 meter, if it still matches at 2 meters, and it still matches at 3 meters. Because you've only provided the one shot from 5 inches above the water, I would say that this might be evidence to support both models. You could say, yes, it shows here that the land is above in the distance, so it could be a concave Earth. And then I could come back and say, yeah, but without any further measurements that you should have taken, then there's no way that we can disclude this from also being representative of a globe Earth. So because there's no way to exclude one or the other, I'm not going to just accept it as positive proof for your own model. I'll still hold the skepticism towards that, and I'll give you an opportunity at any time if you want to present different observations from different elevations, because I believe as you go further up in elevation, you will start to notice that the evidence to support the concave Earth will start going away. It just becomes non-existent. You're only going to get that evidence the closer. You're only going to get that evidence the closer you get to the surface of the Earth or the surface of a large body of water. Now, the rotating sphere to provide gravity, yeah, that could work. This is also known as Einstein's equivalency principle. You really don't know when you're being accelerated around a surface, or you're being accelerated up in an elevator, or you're being accelerated towards the Earth. Yeah.
I don't think Josh said that the Earth is rotating. He thinks the Earth is stationary and the celestial sphere around us rotates.
Yeah, but no. He's saying the concave Earth, I believe, right? Josh, let me make sure that I'm getting this right. You do believe the concave Earth rotates, and it is the rotation that causes the gravity, correct?
No, I do believe that the Earth's surface we stand on is stationary, and that the rotating celestial sphere, not around us, but above our head, smaller than the Earth's sphere, inside the concave Earth. Okay, that's rotating.
So I'm sorry. I'm sorry. I took under the. I thought you meant that it was the your concave Earth that would actually be rotating, causing the gravity from the centrifugal force. So you think the concave Earth is also stationary, but it's the heavens above that are rotating that cause gravity? Now, that's a topic we can talk about. Can you please touch on that topic? I'll yield the rest of my time so that we can go back to that topic, because I did get that mistaken. We can also talk, in fact, we can openly talk about this if you'd like, because I'd also like to discuss the ether with you. Now, before we get to the rotating sphere, let me tell you what my problems with the ether are. During the time of the ether experiments, when they were running these experiments, this is the conclusions that they possibly could have come up with were that the ether was stationary to the Earth moving, the ether was stationary while the Earth moves through it, stationary to the background of the universe, or there was no ether at all. And what the conclusions they came to, that they were drawn to, was that the ether was stationary to the Earth, which is not what they were expecting. They were not expecting the ether to. They were not expecting the ether to be stationary. They were expecting different speeds of lights in different directions, because they assumed that the ether, through their model, would have been stationary to the background of space, and that the Earth would have been going around the sun through the ether, and that's why they thought they were going to get different measurements, and it turned out they really didn't get what they were expecting. The only way their measurements made sense was if the ether moved with the Earth. And this is where the stationary Earth and the geocentric idea comes in, is because our optical experiments if you didn't know the rest of science, if you only stopped at the very basic understanding, you would sit there and say, well, this experiment shows that the Earth is stationary to the medium by which the wavelength of light needs to move through. But unfortunately, we've already shown beyond any reasonable doubt that light requires no medium. And even the people, the people like Michelson Morley and the others that were doing these experiments, they had a hard time understanding this. They had a hard time accepting their own results because their results pointed to something they didn't think would ever be possible, which would be an ether stationary to an Earth and not the ether stationary to the sun or the ether stationary to the background of space. They already knew the Earth went around the sun when they did these tests. In fact, they did the test at different times of the year so they could catch the Earth in different portions of its orbit, so it would be moving through the ether at different speeds and in different directions. So this is, and all these together all pointed towards the ether needing to be stationary to the Earth, and that's not, they've abandoned that. Now, there are scientists that are trying to come back and bring that back to life, but there's simply nothing to support that. Nothing that supports that is not already explained by the electromagnetic field. So I don't, and we can go to the next portion where we go back and forth on that. If you want to start with the ether there, and then we'll get to the shape of the stationary concave Earth. Are you okay with that, Josh?
Yeah, I am.
Josh,
By
if you don't
no.
mind, just before you respond, there's a quick question from the audience. Could you clarify your position slightly? Do you believe we live in a hollow Earth, or is it more of a bowl?
Well, yeah, I think we live on the inside surface of a sphere.
Right,
If there is a hole in that sphere, say a hole in the middle of Antarctica or something, then technically, yeah, there could be holes at the poles. There might not be. I don't know. I've never been there, but it's possible. There's so much disinformation with maps. Just maps from antiquity, and north could be. It's possible that the South Pole is actually the top of the world, and we don't really know exactly what the exact dimensions are, but we know because we travel from A to B, we know it must be a spherical type Earth, and it must be close to spherical. Otherwise, we wouldn't be able to travel that accurately with. They don't fly over the poles very much, so we don't have really much proof of, is it flat near the poles? Is it an oblate spheroid because it's flat at the poles in a sphere? Is it more? Does it bulge like this, or is it a perfect sphere? Those are questions I can't possibly answer, but we know it's. If you plot all the cities, and let's say take 100 cities, the 100 biggest cities, and you connect one city to every other 99 city, and you're going to create a web. That web is going to be spherical. So we're either on the inside or outside of that. So I have lots of questions too, and I'm not, of course, I can't be dogmatic about any of these things that I ponder, but can
I ask you a question?
Sure.
If we were on a concave Earth, okay, and you're saying that it's spherical, in other words, like you said, the South Pole could be at the top, North Pole could be at the top. You still think that? Let me steelman your position for just a moment. Do you think that the concave Earth at the equator has a diameter of about 25,000 miles?
Yeah, I think the spherical dimensions inside and outside are very close. With the exception of
Okay. Great.
Yeah.
Okay. Great. Now, in your model, how big is the sun, or how big do you think the sun is?
The sun is very small compared to the Earth. I do believe that. Yeah, I do believe that the sun is very small compared to the Earth. I do believe that there is an actual sun that orbits about the Earth, but I don't believe that we see that. I know that we all see our own sun. We all see a manifestation, an apparition, projection, if you will. But, certainly this flat disk of light isn't actually setting into the water. So we know that's not the actual sun setting into the water. That's obviously.
So how come the sun does not appear at solar noon for every person at all times?
Why would it? The sun's moving, so it's.
Well, okay. Oh, so the sun has something it orbits as well?
Right. Yeah, the sun would orbit around the celestial sphere. And this is how celestial mechanics have predictability, is because you have a stationary Earth, and the cosmos, the heavens, are inside, and you still have orbiting planets. You still have the retrograde of Mars and Venus around the sun at times of the year, and so there's a predictability there. And so,
so here's what I'm hearing, and well, let me address a problem that is a problem that that is automatically easy to see. Number one, you don't have an explanation for the sun going down towards the horizon. There would never be a reason for the sun to appear towards the horizon in that. I mean, it never goes down. It never gets closer to the surface of the Earth. I mean, you can use perspective, but at the same time, perspective would never bring that down to the surface. The real problem, though, that I do have with it is the daily observations of the sunrise, sunset, and solar noon for people on the Earth. Okay, so solar noon would the sun. I guess I can't visualize how the sun would actually appear due east for every person on Earth. Okay, no matter where they're at, if they're at the bottom of the celestial, or if they're at the bottom of the concave Earth, and the sun is in the middle of the celestial sphere, which is where it would be during the equinox. Let's say it would become, it would be the subsolar point for the sun, which is where it would be. See, that's the thing. There's no such thing as a subsolar point for the sun at that point, but we'll just call it the subsolar point is along the equator, which means that the sun would be directly above the equator circling your celestial sphere. However, somebody in South America, at the tip of South America, the very furthest way that you could get in South America, would still see the sun rise due east and still see it set due west. How is this possible if the sun is small and local and it's rotating around a celestial sphere instead of much larger than the Earth and in place while we spin?
Okay. Well, I'm going to screen share for that. And so am I screen sharing now?
One sec, let me just get that up.
No, I still see you.
No, you're not. You're not. You've left the Hangouts call, apparently.
Yeah, it said it was empty.
Just come back into that same link.
Again. Yeah. Yeah, I just went over there and it was empty. All right, so I'll join. Okay.
Yeah, there we go. Okay, yeah, just screen share from there.
Yeah, cool. Here we go. All right. So you said that I didn't have. I don't know how you knew You said I didn't have an explanation for how the sun appears to set and rise, and I absolutely do have an explanation for that. But first, I'll explain. I'll just, for the audience, you may have looked at this already, but for the audience, this is pretty much what we're talking about in a concave Earth. This is how. Okay, come on. All right, so here we go. So I don't know why I did that. Sorry about that, folks. All right, so in the northern summer, you've got a sun orbiting around, near the tropic here, and then, down as the sun moves throughout the season, throughout the year, the sun's going to move down here and, around the equator, and then the sun will come here. So for everybody, the sun rises in the east and sets in the west. Very simple. And lights up half a sphere, Earth. So that works. And there's a working map. And if there's a hole down here, making the Earth, quote unquote, a bowl, because this is actually, if the north is actually if the north, quote unquote, is the bottom, and this is all upside down, then technically, yeah, we'd have a bowl-shaped Earth with technically and quote unquote ice ring. So,
let me ask you a couple of questions about this model, because this model doesn't have very much explanatory power. Please go backwards to the one that you were just at, so that we could talk about that real quick.
But it does. It takes a lot of it takes a lot of digging.
Well, hold on.
Trying to go back to that.
I've already seen a model like this before. Yeah, it's cool. I'll wait for you. I've already explained away a model that looked just like this.
Okay.
Because number one, your sun goes to the left and then immediately appears back on the right.
What are you talking about?
Well, I mean, go
I don't
back
know.
to the video you were just at
Here we go.
with your model.
Yeah.
Okay,
So this
pause
is
it
wide
real
angles.
quick.
You're seeing
Just want you
all
to
the
pause it.
continents, but in reality, this is a full sphere. So it's just orbiting around
Okay.
inside the
So
rim.
this is right. Okay, now it's a transformation. Okay, so it
Right.
still would not. I would need to see it without its transformation, but at the same time, it still does not explain why everybody sees the sunset due west and rise due east. Look at where Australia is. Okay, look at where
Right.
Australia is now. On the same day that somebody in Australia sees the sunrise due east on the equinox. Now, keep that in mind. Look where you have your line for the sun for the equator. Go back to the one you were just at. Don't just pause it and leave it there for a
Well,
second.
this was a full sphere like you wanted to see instead of the
Okay.
wide angle view.
All right.
But
Now,
I'll go back.
okay.
Here you go.
So, but yeah, I mean, it was easier to see because you could see the whole thing, and I could show you problems with it. The main problem I see is that the people in Australia, they're pointing away. They're pointing south. Well, they're pointing down. Look, stop it right there, just so we can look at this model for a second. You see how Australia is oriented? It's oriented so that it's facing away from the equator. All right. So when everybody, even the people at the bottom of Australia, go to the bottom, like where the little hump is, then it comes back down right there. Yeah, right there.
Yeah,
A person that
we're
lives
Sean,
right there on the equinox.
Sean.
Okay, the person that lives right there will see the sun rise due east. In your model that you're showing right here, no matter whether it's stretched out or not, the sun does not appear to rise due east. It appears to rise north of due east to anybody in Australia at any time. And if you look then at Japan, at the same time that somebody in Australia
It
is
does
seeing
rise
the
due
sun rise due east in Right, I agree. That's why the model has problems, is because there's no way to explain that with having to curve the continents away from each other and have the sun local. In real life, they do kind of curve away from each other, but the sun's a lot further away and it's much, much, much bigger than the Earth. So it doesn't matter. Anybody looking due east is going to see the sun at relatively the center of the sun, because the sun's much larger than the Earth and it's much further away. When you reduce the size of the sun to smaller than the Earth, then that means everybody on Earth is going to have to look at a different angle to see where the sun is.
I don't see.
That's
Here's
what
the
this-
sun rising from the east, due east. So the sunrise is coming. The sunrise
That'd be
happens
sun
for the
setting.
coast
I
first.
think that'd be the sun setting.
This is sunrise.
I think that
So you
would
have
be
darkness
the
before-
sun setting. Right?
No, look, this is the sun setting over
Oh
here.
yeah,
You have
okay,
light,
yeah. I'm
and then-
sorry. Yeah, you're right. I'm sorry. I was just thinking
sunrise-
of backwards on a. Yeah, go ahead.
Okay, so in the Earth, yeah, every light in the sky rotates east to west, and so of course, the flat earthers have no explanation for the southern stars, and so obviously convex and concave don't have that problem, so we don't even have to argue about that. Thank God. So sick of that stupid argument. So we're past that.
Yeah, right.
So this is, and so yeah, I mean, these sun paths are, I mean, it's just an inverted model. So I mean, these sun paths, they're all going to work. This is going to function on the inside or the outside of a spherical Earth, and.
But here's the
I
problem:
wanted
the reason why it can't. But the reason why it can't work is because you're not dealing with a sun that's larger than the Earth. That's the main problem that you're going to run into, is because when you're talking
Right.
about this, right? And I'll stick to this point because geometrically you can't explain this. No matter how you shape the Earth, you're not going to be able to explain it with a small and local sun. Even geocentrists run into this problem when they say that the sun's not 93 million miles away. It's much closer, much smaller, and it's circling around the Earth instead of the Earth going around the sun. every time that somebody brings that argument up, I ask them, how do you explain this? How do you explain this one observation? It's not an observation that I'm making up either. This is an observation that's gone on for a long time, ancient observations. We have ancient monolithic sites built around the equinoxes and solstices. So this is not something that we are just saying occurs or anything like. No, everybody on Earth has been knowing this for a long, long time. And it's been important to our cultures because it represents the changing of the seasons. So in the concave Earth that you just showed me, with the sun needing to be small, when it comes back around, okay, Australia and Japan are going to be facing two different directions. What you're going to get is due east is not going to be parallel with each other at sunrise. Okay, in fact, due east is always parallel to all other due east points on the surface of a sphere. Okay, so in a concave Earth, you're not going to have that. If you go back and you look at that picture, due east for Japan is slightly north of due east for the equator, and it's slightly south for due east for the for anybody in Australia, anybody in the southern hemisphere. So we are not going to see the same projected light. If the sun is small, you're going to have to look in different directions. Each person will have to look in a different direction on Earth based on their longitude. And we don't see, or based on their latitude, I'm sorry, and we don't see that.
Okay, so first of all, let me make sure my mic isn't muted. Okay, first of all, I don't have any evidence that the sun is larger than the Earth or that it's 93 million miles away. And I can also show that this is why I say that the sun manifests differently for everybody, because I don't believe we can ascertain an actual position or altitude of the sun, and I can prove that because we can film the sun, an appearance of the sun, right here in the clouds. Okay, so we can observe what appears to be the sun literally being in the clouds, glowing up the clouds. Now, obviously, the sun is not actually in the clouds. So flat earthers need to understand this is not the sun actually in the clouds at whatever, 3/4 mile altitude, 2 mile altitude, whatever altitude these clouds are at, very low altitude. The sun is not literally 1 mile above the Earth. We can agree with that. Because when we look at high altitude balloon footage,
100%.
we can tell that we never, from 20 miles up, that camera on the balloon is 20 miles, say, 20, 22 miles, whatever, 20 miles up in the sky. That camera, we never have to look way down at these clouds from way up here. We never have to look down to see the sun here. From high altitude balloon footage, the sun never appears in the clouds. The sun always appears up there with the balloon. And we do see a hot spot on the Earth indicating that it is a close, small light source. However, which is it? Is the sun 1 mile altitude or 20? Well, we can observe this in Boston at the same time we can observe this in Los Angeles. So they're obviously, unless there's more than one sun, the sun can't be literally in the clouds in Boston at the same exact moment that it's literally in the clouds in Los Angeles. There must be a different answer.
Okay, so here's another question I have. And this is a question that anybody can use and go look outside tonight. We have a full moon tonight. Okay, the moon appears the same size as the sun in the sky. If the sun is on the other side of the celestial sphere and we can't see the sun, how is it possible that we're having a full moon tonight?
Because light bends around the inside of the Earth, and the sun does provide light to the moon. The sun is the moon is illuminated by the sun, and which
okay,
is
good. You agree on that?
Main reason, which is the main reason for the total lunar eclipse in both the heliocentric and the concave models. Bending light is the answer for the lunar eclipse. Once again, flat Earth.
Well, then how come it's a regular phenomenon? How come it's a regular predicted phenomenon, and how come it's not like has weather and atmospheric conditions have no influence on the light going to the moon? Like we can actually predict it like the future lunar eclipses for the next 20 years, let's say. We can go through and predict it because it's a regular cycle. So how is
Right.
the refraction
Sure.
that's needed to cause the light for the sun to bend around, how is that also a cyclical process?
Well, simply because everything's contained within the Earth and just orbiting around. That's how you have predictability. It's not like in
No,
the
okay, I
heliocentric
understand. I
model.
understand, but
You got all this stuff moving around in outer space and orbiting around this, and galaxies are orbiting other, all this stuff. But in the concave
right.
model, it really is very simple. Everything's in a synchronized timed loop, and the heavens really is
Okay,
a
so
clock.
how
It's like a timepiece,
so okay, so let's say
The sky is
let's say
calibrates
we're
clock.
in the okay, let's say we're in the middle of America right now. Okay, both of us, we'll just agree, we'll meet halfway, we'll be in the middle of America, and we look up and we see that there's a full moon, but we also look up and see that there's no sun in the sky. How does the sun illuminate the moon when the sun is behind the full moon on the other side of the celestial sphere? That's what you call it, right? The celestial sphere? And at
Correct.
this
Yeah.
point, just so I get the model right, on well, just so I get the model right, if me and you are standing in the middle of the United States and we look up and see the full moon, there's a celestial sphere behind the moon, and then on the other side of that celestial sphere would be solar noon for the other side of the concave Earth, correct? Because that's where the sun would be on the other side of the celestial sphere. Do I have that right?
You have a celestial sphere, and you have a sun and moon orbiting around that celestial sphere, moving at different speeds.
Okay.
Now you have a sun project. It's a directional light. So wherever the sun is, like you saw, it's a directional light, and it's orbiting around. But light is also wrapping around the inside of the Earth, bending because of magnetism, and in liquid, of course, because
Hold on.
air is a liquid. So you have light bending around back and entering back inside the backside of the celestial sphere in this concave Earth model. And so because you have light bending back around itself, most of the time the moon is going to be within the sun's light, even though it's not directly aimed at the moon, the backside of the moon is still within the light being projected around the inside of the heavens and the Earth.
Okay, so it's you're saying it's a magnetic field?
Light, well,
Are you saying you just mentioned magnetism? Well, not really, not really. I mean, there's only a few things. We have only a few. Well, our understanding of what photons are and how they act is pretty well understood for the scientific consensus. So if you're telling me that these photons are doing things that we don't normally see them do, then you would need to explain why they're doing things that they don't normally do, how they change the way they act, giving us the regular cycles of the phases of the moon, going from new moon to full moon back to new moon. Okay, so if you can't explain these things in a cyclical fashion with science to back it up, well, then we can always stick with the super easy to understand model of the Earth with only gravity, a larger sun, and a moon that's orbiting the Earth. Everything's consistent with one another. The moon orbits the Earth under the same mechanics that the Earth orbits the sun. We don't need anything special to explain that. The celestial geometry is what determines what every observer on Earth would see the moon as, because there's another problem. Let's talk about another problem real quick. When you and I look up at the moon, we're in different parts of the Earth. However, we see okay, yeah, go ahead.
Let me address that, and then we can move on, because I don't want to move on from topic to topic, and then I have to try to remember all the things I have. You know what I mean? It just gets piled up.
Yeah, sure. I don't want to pile it on.
Yeah. That way we can move on. You had mentioned the moon phases. Okay, so that's easily explained, because there's a relationship in both the heliocentric model and the concave Earth model. There's a relationship between the sun's position, the moon's position, and the light coming from the sun. Okay, so the relative position of the moon and the sun is what creates the moon phases. Just like in the heliocentric model, it's going to be the same thing. You have light moving around differently. It's a different model. Everything's on the inside versus the outside, but it's still the same concept. You have a relationship between
Okay.
the moon and the sun, which
So-
makes up the,
Yeah. Let me explain some things to you that are observational that in my opinion lead to a problem on the concave Earth. Okay. Number one, the phase of the moon is simply due to the geometry of the Earth, sun, moon geometry, celestial geometry. Whatever the position of the moon is in relative to the Earth and the sun, that's what the phase of the moon is going to be for an observer on the Earth. Now, here's the problem I see. Let's say you were much further east than I was, okay? And I was much further west than you were. And we look up, we should be seeing the moon in two different phases. You should be seeing different portions of the moon than I should be seeing. And we can extend this further. Let's just say we go to one end of the visibility of the moon and the other end of the visibility of the moon, meaning the two people can see completely different sides of the moon. Why is it that every observer on Earth looks up and sees the exact same face of the moon when it doesn't match the geometry of a concave Earth?
I'll explain that. And that's what I was touching on before when I said with the sun, it's going to be the same thing with the moon, because the sun is the sun we see is an apparition, so is the moon, and that's why sometimes from high altitude balloon footage you can see the moon kind of rotating and it kind of looks like a flat disk. And so the same thing with the sun. You can see the sun. Actually, Sam did a really good video. I'm not sure where it is, but there's high altitude balloon footage where you can see the sun kind of rotating as a disk. My point is that there's a tangible physical sun and moon, and that relationship creates the phase. And so that phase is going to remain. It's going to be the same phase up in the heavens. The sun and moon relationships isn't going to change based on an observer's position. The sun and the moon's position are the sun and the moon's position, regardless of the people. And so that phase is going to be projected to every viewer. That's why everybody sees the same phase, even though they're in a different position, is because everybody's seeing a projection of that phase. And so everybody sees
Do
the
you
same
have proof of this projection? I mean, that's a very hefty claim that you just made there with zero actual evidence.
Well, you don't know I have zero actual evidence. You just haven't seen it yet.
Well,
And
yeah, you're
so-
right. You're right. I'm assuming that you have zero evidence because I haven't ever seen it before. But I would love to see your evidence to suggest that the moon is an actual apparition, or the sun is an apparition, and the moon is.
Okay.
I mean, you believe they're physical objects, right? You do believe that the sun. Do you? I'm sorry. Do you believe that the sun is an actual physical object?
I do. I don't have any proof of that, but I do believe there's a actual physical, tangible sun. I just don't think we're seeing. I think we're seeing a manifestation of it, a projection of it. And so,
How do you? Can I ask you a question? How do you think the sun generates its light?
well, that I don't know. That I would have to be literally like in the heavens or the
I
creator.
mean, this is something that's pretty well known with science. You know, I mean, we can create these same processes here on the Earth and get similar results. I mean, we're not creating stars, but we're doing, we can do nuclear fusion here on Earth, and we get similar results that help us explain what we see in the sky. And they help us explain what we see not just in our own sun, but in distant stars as well. There's so much explanatory power that comes with astronomy and the cosmology that we already understand. And what you're suggesting is an abandonment of those ideas and that science for, and I don't mean, I'm not trying to sound mean here, but ignorance, for something that we don't understand,
No. I don't want an abandonment of anything. Actual science actually welcomes challenge. And so it's okay to consider other ideas. And in the end, even if the original hypothesis was correct, that's fine. We only proved it more. And so I don't.
Oh, I agree.
Certain people need to reject science in order for their model to work. And so I don't necessarily cling to any particular model. I do believe water curves up. We live on the inside of a type Earth.
Okay.
However,
So
I don't
now
want to reject science, but I think it really is time to rethink everything. And And just because an observation has an explanation doesn't mean that explanation is correct. And so there's going to be many
100%.
explanations.
I agree.
And only one of them, if any, only one explanation at best can be correct. That means all explanations for any observation, they're
Right,
most likely all wrong,
but once,
except one. You know what I
right,
mean?
but
So,
once you have once you have solid evidence to disclude one of your models, you should abandon that model. I mean, you shouldn't say you might learn later that you made a mistake in doing that because you were misunderstanding the science, but and something that's understood as what we understand our cosmology, when it's something that's that well understood, you'll run into problems that have direct like conflicts with your model. I've named a few now. There's distant starlight. Why are we not? Why do we see distant starlight? How is it that we can that we see events happening that are, you know, millions of light years away? We're seeing them happen now. You know, how is it that how are we seeing this? What about the redshift? Like, how are we? What are we getting wrong in cosmology when we look up at the sky and we see things and we come to the conclusion that they're millions of light years away or billions of light years away? What are we getting wrong with those readings? Because we see direct correlations. Like, we look, things that are further redshifted are younger galaxies. So we see things that are further away are younger in nature. So the light, you know, those are the things that are the beginning of the universe. The things that are closer are much older. So we see there, but the redshift on, I mean, they're much like older to us. You know, we're seeing them in an older state. So their light that's come to us has taken less time to travel, and it's backed up by the redshift that's coming from these galaxies or stars or whatnot.
Okay, first off, I want to say that there's many things that will appear to debunk a model, and when I say there's many explanations for an observation, just because someone thinks they've found an explanation that works for that observation, they might be correct. There might be several explanations that work, and that doesn't necessarily you can't take one explanation for one observation and say that works, therefore this model is debunked. That works in this model.
Okay.
Therefore, this model has to be debunked. So a lot of things can work in a lot of different models, and this model has a lot of puzzle pieces, and it takes an understanding of our view of the sky and how this model is actually being presented to you. There are very good explanations for this model, and most people just haven't heard them. They look at the CGI model and they say, aha, this wouldn't work, this wouldn't work, this wouldn't work, this wouldn't work. But they actually think there's a tangible sun in the sky 93 million miles away that's a ball of fire. And, you know, they have a lot of possible,
well, okay, I want to ask you something real quick, all right? So I want to ask you this real quick, all right? We have some numbers that you've given us and to work with, all right? You said it's 25,000.
Real quick, I still want to touch on how the sun sets, but I'll do that after.
Okay, well, yeah, we'll come back to that afterwards, all right?
We'll come back
so
to that.
we take 25,000. Yeah, well, let's take 25,000 mile circumference of your concave Earth, all right? Now, we're saying it's just we're going to say that it's basically the Earth flipped inside out. So instead of it being curved in, like in on itself, it's curved inverted, like around it. You know, it's just basically, yeah, it's inverted, all right? So that means the diameter of this inverted Earth is also going to be the diameter of the Earth, which is about 8,000 miles. We're just round that to make it easy, right? So the distance to the center is only 4,000 miles away. All right, so that's the center of the celestial sphere. So some distance between the surface of the Earth and 4,000 miles away, we're going to run into the moon, correct? Yeah, okay. We could, why do we not flash off radar off of the moon and receive that radar signal bounce back to us, and it'll tell us that it's only 3,500 miles away instead of, you know, 280 or 260, whatever the number is, 400,000 kilometers away, 380,000 kilometers away.
It's because
how come we can't do that?
I think there's been a fundamental flaw in the way we calculate distances of the sky, because I don't believe that NASA has actually traversed the universe in the accepted heliocentric outer space.
Well, of course not.
I do
Yeah.
believe
Okay.
NASA. No, hold on, time out. I don't believe everything the flat earthers do.
All
I
right,
do
go
believe
ahead.
NASA's going up there and doing stuff in the sky. But I do believe that that science has got the way they calculate these distances. There's a fundamental flaw there. I don't believe we have anything light years, billions of miles away. I think there's a mistake there, and it's almost like a
Where's
game of
the mistake
telephone.
happening though?
Once you introduce error into an equation, every domino that falls, now everything's going to have error, and so we've probably had that
Right.
for hundreds.
But the speed of light,
hundreds of years.
the speed of light is fairly well known. The speed of light is fairly well known. Okay. It's a calculated value. We've measured it really close to the calculated value, but it's a calculated value, and we'll go ahead and say 300,000 kilometers per second. All right. That's roughly what it is. Now, what is it about that measurement that would keep us from being able to measure the distance to the moon? Because we can easily bounce radar off of that distance and receive that radar back and measure the time it takes for us to send the radar signal and the time it takes to get back, and can calculate the distance based on that time and the speed of light.
In the accepted outer space model, you have a vacuum. You have a vacuum, an infinite void of atmosphere. In the concave Earth model, you're not dealing with a vacuum. You're dealing with an unknown heavens with unknown liquids up there, with unknown barriers, with unknown different phases of water. I don't think we have just liquid, solid, and gas. I do believe there's four.
How come the water's not following? How come the water's not falling on us then? You admit gravity as, whether you admit that gravity is caused by an external source or by what we believe it in. You have said there's some kind of force that causes things to head towards the surface. So are you now saying that there's water that's lighter than air?
What I'm saying is that, well, number one, water's diamagnetic; it'll bend. Number two, these forces, whether you want to call it gravity or gravitational forces or universal compression or etheric pressure or magnetism, whatever, these forces, plural. I don't think we have gravity, a one directional force holding everything to the outside of a ball. While that might be possible, I don't think that's what we live on. I do believe that the gravitational forces are plural forces. There's multiple upwards and downwards forces. Kind of like you put a basketball underwater, water pressure forces it up. So that's an upwards force. That's just simply water pressure. It's just two relative mediums, air and water, which are both fluids. It's just they're two different. And so basically, when you put a basketball in the air air pressure is going to force it down. When you put the basketball in the water pressure is going to force it up. All that basketball.
All right. Hold on.
It's just trapped in between.
But I want you to explain an observation for me then. Okay, but if I want you to explain this observation for me. Fight the Flat Earth. Will you pull up the video of the bubbles in the water when it's in free fall, please?
Sure.
Okay, now I'm gonna break this observation down. I'm going to break this observation down for you, and then I want you to really, I don't expect you to have an answer for it tonight, okay? I'm going to accept the fact that you're probably not going to be able to give me the best answer tonight, and I want you to think about what I tell you and what I show you here, and I want you to try to come up with an explanation that actually matches what we see in reality, okay? And we'll wait for Fight to pull this up. Now, I'll go ahead and explain it a little bit right now so I don't have to do it while it's happening, but, okay, so gravity, as we know it, gravity is a force, okay? Is a singular force. It pulls to the center of the Earth, okay, the gravitational center of the Earth. Give me 1 second before you start this Fight. Let me explain what's going on. So at the beginning, he's blowing bubbles into the water. Now, how the buoyant force works, it requires gravity. It requires an acceleration in this in the equation. The water is all being pulled down, but it's also having to support its own weight by pushing up as well. So when you have a pocket of air inside of the water, it pushes up on the air, and the air doesn't have enough mass to push back. So it rises up, okay? Now, when you
Correct.
drop this bottle, and you can go ahead and play this now. When you drop this bottle, okay, I'll let it drop so you can see it. I promise he drops it. Okay, you see the bubbles, how they're not rising? They're just kind of sitting in place. Well, that's because... Well, okay, go ahead. Yeah, okay, because in this situation, it's all has to do with Brownian motion, just the random motion of particles at that point, okay? Because in this situation, it's a little different because it's not really dropping in complete free fall because there is still some kind of surface area on the bottom that's going to have some kind of air friction. So you're going to be dropping at really, really small, you're going to have microns of force in there, like real micro forces, you know? So when you drop this, here's what's happening. You have gravity pulling down in one direction. In the other direction, you have the accelerating, the inertial force. This is the same force you feel in a car when you step on the gas and you feel yourself being pulled backwards. You understand that the inertial force is due to acceleration, correct? Okay, so in your reference frame, in the reference frame of the bottle of water, you have the force of gravity pulling down, plus you have the entire reference frame accelerating down, giving you an inertial force in the opposite direction. These two forces act on each other, and they're equal and opposite. Right. Therefore, it comes out to zero. And when you put zero in the accelerating equation, and you do that, it doesn't matter what the masses are, it doesn't matter what the densities are, it all comes out to zero because you have the zero for the acceleration. There is no buoyant force once this bottle becomes dropped. The buoyant force is gone. And you can tell it in two ways in this video. The first way is that the bubbles stop rising. They just kind of hover in place. The second way is that the bubbles become more spherical instead of flattened out like a pancake. Now they're flattened out because of the pressure of the water on the inside pushing on it, squishing it together. When it's in free fall, though the force that causes that pressure is canceled out by the force of acceleration. Sure. Therefore, the bubbles are no longer squished; they're more spherical. Now, I would like to know how this works on a concave Earth.
Okay, so first I'll start off by saying you're probably used to debating flat earthers that claim that gravity is quote unquote false, and so I don't hold that same exact position. What I'm trying to get at is I don't. Flat earthers will say gravity is bullshit. It's just buoyancy and density. Now, gravity is bullshit, but so is density and buoyancy. Okay, and when I say gravity is bullshit, I don't mean those forces don't exist. What I'm trying to say is the way those forces exist is misunderstood. And so when I say that, like, you still have in a concave Earth, you'd still have your gravitational constant. You'd still have your 9.8 meters per second. All these different sciences, it's not that they all have to be wrong. It's not that the way science understands gravity and the sciences where they can use equations and measure and predict and successfully predict, it's not that all that has to be wrong. I don't agree that all that's wrong. All I'm saying is that I don't think that force is coming from below us, pulling us down. From force generating.
Fight. Joshua, I am so sorry, man. I have a family emergency that's happening right now. I need to step away. Fight, will you take over while I take care of this?
Yeah, sure.
You know what it's about, okay. Fight, because my son's on his very first long distance car trip, and on his way home he got in an accident. So let me take care of this. Fight, will you please just take over? Fight, I'm sorry, Joshua, I'm not trying to get away from talking to you or anything like that. I just really need to take care of this, man. I'm so sorry.
Okay. I hope everything's okay.
Where did we get to? I'm sure that everything is okay with team, but we can keep this going. Where did we get to? I've been trying to pay attention to the chat as well as you. So you guys were talking about the sun as well, weren't you?
Yeah. Well, let me just finish what I had to say about gravity, and we'll carry on with how the sun sets, which is something that he wanted to. He'll come back and watch this later, but for the audience. So what I was saying was I don't believe we have these gravitational forces, plural. Which is why I say gravity is false, is because they people understand gravity as a force. There is one force called gravity. And I don't believe gravity is a force. I believe gravity was a name, a label used to describe an experience of things descending 500 years ago. Now we call them gravitational forces because we do understand that it's not a singular force called gravity. It's gravitational forces. It's many things. And all I'm saying is I still believe that all these sciences with gravitational forces are real. I just don't believe that they're emanating from beneath our feet, pulling us down. I believe they generate from above our heads, pushing us down. And the piece of evidence that I'll use...
What is the nature of the force that's pushing down?
I'm sorry?
What is
the nature of the force could be the same. It could be it's just, I'm just saying it's coming from above us, not from beneath us. And the reason why I think that is because one thing that triggered this in my mind, I was like, wait a minute. When I saw Shazwar Boogdi do the slinky, he just held out a slinky, and he let it stretch out like this, and he held it out like this. He was in a park or something on the grass, and he filmed it. He filmed himself just holding out a slinky. And when he let the slinky go like this, and the slinky was in quote-unquote free fall or whatever, the bottom of the slinky didn't budge. The top of the slinky started to descend like this, and then when it compressed, it all started, that
would be to kind of do with the elastic forces within the slinky. But if I could just quickly respond to
the bottom of the slinky didn't start to move up. The bottom of the slinky remained and so that's not proof of anything. It just got me thinking maybe this force is coming. It's still a downwards force, but maybe it's coming from above us. Maybe gravity. I'll just say it, gravity. Okay, gravity is coming from above us instead of below us. And the math, the equations. I don't think the science, the predictability, the 9.8 meters per second, all that is true. All the experiments don't have to be wrong. And
now, if I could respond to the suggestion that gravity is coming from above rather than below, I just want to play you a quick video. It's just like a minute long, okay?
Sure.
First, we weigh a small lead pyramid to measure the force of attraction between it and the Earth. Its weight is 152.166 grams.
Ruben told me about this. There's something wrong. I forget what it was.
Now we move the heavy lead ball under the scale, adding its mass to the mass of the Earth. The weight has increased by 1/1000th of a gram, which represents the attraction between the pyramid and the ball.
Now, the reason I've shown that is because that demonstrates that there was something below the pyramid that was giving it its weight. And then when you added an extra mass on top of the mass of the Earth, it increased that weight, because weight is a force. It's mass times the gravitational acceleration. So that demonstrates that it's not something pushing from above. It is... I mean, pulling isn't really the right word to describe gravity anyway. When you get into high-end physics, it's much more about energy distribution and stuff. But what this demonstrates is that adding a mass underneath something increases its weight, i.e. its gravitational attraction downwards. And I think that kind of disproves the notion that gravity is coming from above.
Well, that has to do with understanding what gravity is or isn't, because the accepted understanding is that mass attracts mass, which means and that's what they're trying to. That's what that experiment was for. They're trying to show that this little weight weighed this much, and then when we add another piece of mass near that object, it changes the weight, because that must be mass attracting mass, and these two objects are now interacting with each other, and we can see the evidence of that with these gravitational forces. But that doesn't necessarily, just because we can sense a difference when we introduce that ball under the weight, just because we can recognize a difference doesn't necessarily prove a model. All it means is that there's an interaction occurring. And so it's very possible that quote unquote gravity is in the air, and the air the gravity in the air is causing these two objects to come together, rather than
Gravity is
each
in the
object
air.
having its own gravity. You see what I'm saying? Either way, gravity. If gravity wasn't in the air, then how is gravity making this? How
Well,
is the gravity must be
I mean,
moving,
when you're
the
describing
gravity
gravity
waves
as a
are
force,
moving
that's
through the
more of
air.
the kind of classical Newtonian
Gravitational
explanation
waves,
of it, right?
you know.
But
Well, the
what
gravitational
gravity
waves
actually,
are moving through this
yeah,
and pushing it
let
down.
me explain what gravity actually is, as we understand it, is the uneven distribution of mass literally warps space-time around it. In the case of the Earth, it's warped space-time so that everything falls towards it, and that causes an acceleration of 9.8 meters per second squared. And this has been demonstrated in lots of ways. Recently, they've kind of confirmed Einstein's theories around space-time even more, because they've literally observed a neutron star churning up space-time. The light coming from behind the neutron star to in front of it has been warped in such a way that matches Einstein's equations around what mass does to space-time. So it couldn't be just in the air, because that's not what it really is. It's a literal warping of the fabric of the universe in such a way that things fall towards the larger mass, or accelerate towards the larger mass. It changes its geodesic, so the geodesic is always towards the larger mass.
The problem is that we don't have any real photographs of anything from the universe. Everything is all computer generated.
I could show you some very good ones right now.
Okay,
Let me show you this for a second.
we'll just.
Where do you think this is from?
I don't believe that's a photograph.
It absolutely is, and I can show you the equipment that was taken with, because it's done by a very good friend of mine. Where is the camera? Okay, so he uses this setup, which is a decent telescope. That red bit on the bottom of the telescope is the camera that's linked to the software he has, which looks at a point in the sky and then uses long exposure and layering of images to take photos of the sky. He's got some amazing, like all of these images are things that he has managed to personally take himself. And he's done it live for us to show that these are just photographs that he's taking. There is nothing in between the camera and the telescope. There's no software at work apart from the targeting software, which is what he uses to look at certain points in the sky. You know, that there is no programming within the telescope or the camera that can change what you're seeing. So all of these things are literal physical photographs that have been taken by a guy called
Those
Geistview.
are beautiful. Oh,
yeah, they are. I've
really
got
cool.
this one.
That's
I
really
actually
cool.
had him send me.
Does he have a channel? Can you plug his channel so the audience can go?
I don't think Geistview has a channel, but you can find him on Twitter at Geistview. This particular one, I had him send me a really high definition version of this, and I've got it on a canvas on my wall. And he does sell some photos and stuff. But this shows what we see in the sky.
I don't believe that these are crazy distances, and I think all this could still be nebula, which means cloud. I believe all this could still be within our heavens, within the concave Earth at closer distances. But when I said fake, I've seen so much fakery from NASA, and flat earthers are guilty of this, and I just provided an example of that. You look at something and say, oh, that's just fake. And so thank you for providing evidence that is not fake. However, I don't think it proves any outer space. I just have a real hard time. The only people that traverse outer, we have to trust. Of course, any astronomer can take photographs. Mm-hmm. And so we don't have to look at an astronomer that's taking photos. Just because an astronomer takes photographs and believes the heliocentric model is true doesn't mean his photographs are invalid. And so I accept these as real photographs, and I believe those are actual lights in the sky that he's looking at. However, the only people that claim to have proof of these vast distances are the people that even the flat earthers know they're full of they're lying their asses off. I mean, they've provided so much fake stuff. They've provided so much. I've seen so much.
I think the whole NASA fake
flat Earth land
argument is an entirely different conversation.
I'm starting to think that flat Earth is working with NASA. I honestly think that that NASA's fueling this little flat Earth joke. I think it's a joke. You do too, right?
No, I
Don't you think flat
NASA
Earth is a joke?
I think flat Earth is an absolute joke. Yeah, it's absolutely
Okay,
hilarious.
all right then.
You know,
So I'm not
but
not
I
crazy
don't
then,
think
right?
that NASA have faked things at all. I think what NASA shows us is what they're actually showing. And there is, you know, I've personally ripped apart every NASA fails video that I can find to show that they haven't been faking these things. You know, the technology doesn't exist. AR contact lenses do exist, but they're so rubbish they can display a 2D image in green and black, and that's about it. Only just several pixels. But I think the whole NASA fakery argument is an entirely different thing. But I think we should move on to...
That's where I agree with flat Earth.
Listen, guys, I'm back. Listen, I'm back. I'm not gonna be able to stay. You talk about bad fucking luck happening over and over and over in my life right now. My son got in a car accident and flipped his car today. Yeah, he's fine. He's 3 hours away from me right now. Yeah, he's fine. He's fine. He didn't get hurt, but at the same time, man, I have to leave. I mean, I can't stay. I have to get on the road and go get him.
Should we wrap this up?
Feel free to continue this on as long.
Well, your stream.
Well, I was gonna say do it as long as you want, but once you're done.
The stream.
Oh yeah, you're right. Okay. Did I not already do that for you?
Maybe in one of our messages, but we talk so much.
Yeah, you're the only one that can stop the stream, huh?
Daddy Bigcock at gmail.com, and the password is
just send me your
cockalicious 24/7.
Yeah, just send me the your email address and log in, and I'll stop the stream when we're done.
Yeah, and you can stop it at any time, but yeah, sorry guys, I really do apologize for this. I'm not trying to get out of this or anything.
Yeah, just send me those. Send me, dude,
I knew I shouldn't have sent him. Okay.
Just send me those links and
all right. You guys, thank you everybody for coming out. Thank you guys for the super chats. I'll read off all the super chats next week.
So I can read
next
them off.
live stream. I'm so
access
sorry.
to your channel. I can read off the super chats and stuff. Don't worry, I'll take care of it.
Okay, I'll send you the stuff right now.
Details and go deal with your stuff. Okay.
Cool.
Okay, I will right now. Bye. Thank you everybody.
Peace.
Bye.
No worries.
All right, take care. Hope everything's all right.
Oh man, before the stream, Team and I were talking, and he's like, "Oh man, I'm so nervous. My boy's on his first ever road trip away," and I'm like, "He'll be fine." Fucking flips his car. Typical.
I understand that type of bad quote. So, I don't like the word luck, but all right. No. So we'll continue.
Yeah. How about we get back to the sun, because you said you had some evidence about how the sun sets.
Sure. All right, so you can see my screen share?
Let me just get that up 1 second. I've lost the screen. Where is it? There it is. Okay, right, yeah. Right.
Am I still? Yeah, I'm still screen sharing. Okay. Yeah. Okay, so real quick, this is just a little video that I had to show for Flat Earth Land, showing that you know, you can have we can have spinning objects floating in the air. Okay, so Flat Earth Land needs to accept this scientific observation
Flat Earth
as
is all
reality.
Idiots, we know this.
Regardless of how you want to explain this, this is showing you this is possible. Now, this, you use evidence to say, aha, we could have a spinning ball Earth. Okay, fine, we could have a spinning ball. You could use this and say, aha, we have a rotating celestial sphere within the concave Earth. Okay. So, but both sides should be entertained. The only side that should not be entertained is the side that says, oh, that's CGI, that experiment's bullshit. That's not real. The people who refuse to accept this, those are the people that should not be entertained. So
agreed.
I'll move on now.
Yeah.
I'll move on. The sun. Okay, right. The sun setting. That's what we're doing. Okay. So first, understanding that the sun we see in the sky may not be the actual sun. It might be an apparition or a manifestation or, something else. All right, so I forget that video. I'm looking for a particular video.
Pardon me.
Give me one. This is a long playlist. I'm sorry. It just got a little bit shorter because we had a substantial source of information kind of leave the scene a little bit. So I'm just looking for a certain video. These are all in order of length, so I'm trying to... I'll know the thumbnail when I see it, so just give me bear with me.
No worries.
1 second. This is a great video right here. Everyone check this out. The illusion that defines our boundaries. Check that out. I don't know if we're really seeing 1,000 miles, but check it out. Okay, this is the long video. Okay, so it's not... Oh, this might be one of the videos that I lost. Oh, yeah, you always see the front of the sun. Yeah, that video is not there. Okay, so anyways, so you've heard of the movie The Truman Show, right? Okay, so
Yes.
So everyone's heard of that movie where this guy lives basically in like a dome. Okay, so that's what I believe is happening within the Earth. I believe, I do think that... So what I'll do is as I talk, I'll just let this video play.
Okay.
So each person has a limit of their vision, a viewability range, where based, obviously it's subject to change, based on the atmospheric conditions, from one day to the next, or one location to the next, or one season to the next, whatever. So because you can see a plane, right, an airplane that goes over your head, okay, that appears to rise and set, but it's just leaving the vanishing point of your perspective, which does not prove a flat Earth. Perspective and the vanishing point of convergence are real things, and they can exist on a convex Earth, on a flat Earth, or in a concave Earth. Understanding perspective and point of convergence does not prove a shape of the Earth. So I just wanted to state that. So because I understand that if you look at this thumbnail, it looks like, everyone sees a little dome over them. And this is why we see the stars. This is why, in my opinion, why people think they live on the outside of a convex ball with the stars outside the Earth. I understand I understand the rotating heliocentric observations of the sky. I get that. But it could also be explained with a rotating celestial sphere and inverted light. If our view of the sky is inverted, when you actually look at time lapse of the stars, you can kind of see, it does kind of look like you're on a ball rotating in a vast outer space, but it also looks like it also does kind of look like you're on a stationary surface with the stars moving in unison above you. So the observation can be explained with a moving Earth or with a moving sky, simply because the Earth is moving relative to the sky, or the sky is moving relative to the Earth, or both. But you cannot have a stationary Earth and a stationary sky. That's what we cannot have. No. Because we know where the light moves, or the Earth moves.
This is why optical experiments, looking at the way the sky moves, isn't really conclusive, which is why they use things like interferometric fiber optic gyroscopes. And the interferometric fiber optic gyroscope completely disproves the notion that we aren't moving because of the function of the device. The way that a fiber optic gyro or a ring laser gyro, the way that they work is that they can only detect a change in velocity and acceleration. They can't measure what is outside of the fiber optic gyroscope. So there's no way that we talk about Bob and his 15 degree per hour. There is no way that 15 degrees per hour was anything other than the gyroscope physically moving 15 degrees per hour. It couldn't have measured the movement of the sky because there's no way the movement of the sky could have affected the light inside that fiber optic gyroscope.
Unless, because it's detecting movement. It doesn't necessarily mean it's detecting movement to the Earth.
No, it literally does by the function of how it works.
I think it's detecting the rotation of gravity. I think gravity is rotating, not the Earth. And so it is detecting movement. But that doesn't mean that the movement is the Earth. It means that there's movement, there's relative movement between. There's got to be relative movement between two entities, and so that's what the gyro is. The gyro is detecting movement, but I don't think it's detecting the rotation of gravity within the road. See, in the heliocentric model, gravity and Earth are the same, and so they rotate together. In the concave Earth, you've got a stationary Earth with gravity rotating, and so you've got something like I said in one of my
the thing is about the fiber optic gyroscope is that it doesn't need gravity for it to be functioning. That's nothing to do with it. Now, if I could just talk you through the illustration of how one works, right? So the blue box will fire a laser. The white line is a silver coated mirror which splits the beam into two paths, okay? The blue path and the red path. Now, if the gyroscope is stationary, what that means is that once the light on both paths completes its circuit and gets back to the point and goes off to the left there, it wouldn't register an interference pattern. Now, if the gyroscope is moving, as in this animation here, what that does is it physically changes the distance the light has to travel because the path is moving. And what that does is result in an interference pattern in the light when it recombines at the other side of the mirror. Now, there literally is no other explanation for that other than it's measuring the physical change in position. It can't be measuring electromagnetism because light doesn't have a charge and is therefore not affected by electromagnetism. It cannot be measuring the movement of the sky because there's no way for that path that the light is traveling to know what the sky is doing. The only thing that fiber optic gyroscope can do is measure the movement of what it is actually on.
Yeah, I just...
There's another video that I can actually quickly show. One of mine, actually. I'm pretty sure Brother Ernest has been sharing this video with people. So let me just... Well, it's actually one of Wolfie's that I used, but let me just get the video up so I can show you what I mean.
I use one of Wolfie's videos too.
Movement. Sorry?
I said I use one of Wolfie's videos too, and it's no longer at his channel, I noticed.
Right, okay, so yeah, this is the video I want.
Jefferson Aviation one.
Right, so...
It's the ones with all the flight routes in the southern hemisphere inside the Earth that disprove flat.
Okay, right, so...
If I'm on an airplane and just say this is the...
Shush, Bob. Right, I'll get to the point where Wolfie is demonstrating what I mean.
Yes, Bob.
Yeah, cheers, Bob. He's helped me loads. Where is it? I can't find the bit I'm looking for.
Eric Dubay. I'd love for him to speak up. We've heard enough of Bob.
Eric Dubay is just a massive moron and refuses to actually talk to people. Right,
I actually know that he's smarter than he leads on.
So here we go. Right. So what this is one of Wolfie's gyros that's inside one of his very expensive drones. And what he's done is he's positioned it on a globe Earth relative to his position where he is now. And what he does is he moves the gyro. He moves the globe, so the gyro moves with it. Right. So inside this is like a ring laser, like in Bob's thing. And as he moves that gyro on the globe, I'll show the computer in a sec. What it shows is that it measures the physical movement of the gyroscope. So that gyroscope is technically rotating in 3 axes because it's on a globe. And what that shows is as he rotates that globe back and forward, the motion of that is detected, and it's nothing but the motion. and you're just moving it back and forward, and it's registering that literal movement backwards and forwards, and that demonstrates that there's no way that a fiber optic gyroscope or a ring laser gyroscope is doing anything other than measuring the change in position of what it is on
relative to
distant stars in the universe, if you like, because the reference point of the gyroscope is the universe. The gyroscope will measure the movement of whatever it is in within 3D space, or whatever it's on.
If you want to understand the universe, think in terms of energy, frequency, and vibration.
Yeah, but none of those things can affect a fiber optic gyroscope, because a fiber optic gyroscope or ring laser gyroscope work with light, and light isn't affected by electromagnetism or vibrations or anything. Light cannot be changed based on a magnetic field. So it kind of disproves the notion
light
that
cannot be changed. Well, that depends on how you define light. If light is just a perturbation, then light.
Well, let's think of light as a wave for classical principles.
Light is a result. Light is a result. It all depends on how you define light.
Well, there's a lot of ways to define light. You can define light as a probability wave.
And light do have a relationship. I do believe magnetism does.
For the purposes of what we're talking about, we can consider light a wave. I know it can behave as a particle in a wave, and it's actually more a probability, of where it's going to be and stuff. But for what we're talking about, light is a wave, and that wave has no charge and literally cannot be affected by heavenly energies or a celestial sphere or the movement of the sky. There's no way for that gyroscope to detect anything other than what it is on and the movement of what it is on. So for me, the Bob is one of the biggest people for actually giving evidence for a rotating Earth. And the thing about the fiber optic gyroscopes is that they don't just detect that 15-degree movement in 3 axes. What you also notice is that it will detect a 1-degree drift a day around the sun. So a fiber optic gyroscope can literally measure all the movements that the Earth is doing around the sun and around its own axis. I mean, it could even.
Well, you mean the 1/7? You mean one what? You're talking about like 1/70th. Say that again.
It's about 1 degree a day. So 360 degrees in a circle, 365 days in a year. So roughly, the Earth moves around the sun 1 degree a day, and a fiber optic gyroscope can pick that up.
Okay. Well, I mean, the sun being in a slightly different position every day, I mean, that could easily work inside the concave Earth. The ring laser gyro, where he mounted it on the outside of that globe, and then he moved the globe, and then you saw on the screen where just the motion of the gyro itself was measurable. It showed that.
Yeah.
So, yeah, go back to this. All right, excellent. All right, so let's get to the nuts and bolts of this. So he's on the screen there. Okay, so it shows.
So you can see it shows got the pitch and the roll there, and the yaw on the other side, and that shows that it matches the movement
shows that
of the
its
globe.
Relative position. It's relative. So this right here, I'm still screen sharing, right?
Let me get your screen up. Sorry, I've got a whole bunch of things open.
No, that's okay.
Okay, yeah, you're screen sharing.
Okay. Oh shit, it's gonna do that because I'm trying to. Oh, you know what I'll do? I'll pull up because I'm just trying to show everybody my arrow on your video. So I'm just gonna do this.
Oh right, I see.
Real quick. I'm sorry. Bear with me, real quick, folks. I didn't have this page open for a reason, but I'm gonna do it now. All right. So I'll just mute this. All right, it's already muted. Okay, so we're gonna skip this, and that way people can see what I'm talking about. Okay. All right. Oh, but shit, that's not going to work either. All right.
How about if I send
Forget
you the link to the video?
No, that's fine. Forget it. We'll just go back to your screen. I guess I'll just stop my screen share. We'll just go back to that. Okay. So you see here on the computer screen, on the computer screen, you see where it kind of looks like a drone.
Yeah, because this is a fiber optic gyro that is from within a drone. So this is all the software of his drone. This is what he would be using to, see what the drone was doing. So he's just plugged it straight into his computer, and the computer thinks the drone is doing these movements because that's what the fiber optic gyro is doing.
Okay, so all right. Let that video play for a second. Pause. Right now. Pause it. Or something. Yeah, close. Or yeah. All right, good enough. All right. So what we see mounted on that, perfect, right there. All right, perfect. So what we see right here, mounted on this globe with the wire, the brown wire hanging down.
Yeah.
So this is the measurement device right here on the globe. So what is the drone? So I'm just trying to understand this experiment more.
So
before I try to explain
what that is on the globe is an
interferometric
interferometric fiber optic gyroscope that normally sits inside one of Wolfie's drones and allows the drone to know if it's level or not, and obviously
its orientation.
Yeah,
right.
So he's affixed it onto the globe relative to his position. So facing north to south, the way that he is aligned, and it shows that if the Earth was rotating, then the fiber optic gyroscope would pick up that movement of the rotation.
So what is the drone needed? I'm failing to understand what the drone is needed for.
Well, the drone is just a demonstration of the movement, a representation of the movement of the fiber optic gyroscope.
Okay, so one of these fiber optic gyroscopes is normally in this drone.
Yeah.
And so what was done was it was taken out of this drone and put on the globe.
Yeah, so that he could demonstrate a physical relationship between the movement of the fiber optic gyroscope and the measurements that it would pick up. Now,
because what this device is for. It's this device right here on the globe that's normally in the drone is made to be able to detect its orientation relative to the Earth's surface.
Yeah, well, relative to whatever it's on. So because it can detect motion in 3 axes.
But if it's normally in the air, then if it's normally in a drone in the air, then it's not normally on anything.
Well,
what is it?
It's on the drone, and as the drone would pitch left and right, it would detect that movement, which allows the drone to level itself automatically and stuff because it can detect if it's moving with the pitch or the roll or the yaw. So what is on the globe there is very similar to Bob's fiber optic gyroscope that, as Bob says at a certain point in this video, literally as soon as that grey box there is Bob's fiber optic gyroscope. Where's it gone? Right, yeah. So, I keep skipping past it. So that grey box there is essentially the same as what was just on the globe. It's a fiber optic gyroscope.
Bye, Nathan.
Hi, Nathan. And what Bob says in this video that I covered is that as soon as they switch this thing on, it straight away starts detecting a 15 degree per hour drift in 3 axes. And all it's doing is sitting there on his desk. His desk is attached to the floor, which is attached to the earth. So it's detecting the physical motion of what is on. He tries to explain it away as some kind of toroidal field of energy coming from the heavens. But as I've explained, that's an impossibility for the fiber optic gyroscope to register because light doesn't have a charge and wouldn't be affected by any kind of electromagnetic radiation.
I'm sorry, you cut out there for a second. I'm not sure.
Sorry, right.
Could you say that one more time?
Yeah, so what Bob shows is that as soon as he turns this thing on, as soon as he connects it to his computer and turns it on, straight away, it's registering that motion of 15 degrees in 3 axes, right? He tries to explain it away as a toroidal field of energy from the heavens, but as I explained, that's impossible because light doesn't have a charge and wouldn't be affected by any kind of heaven energies or electromagnetic field or anything. So again, what this gyroscope is detecting is the physical movement of the Earth.
And it's using light to do that?
Yeah, light within it.
So then, if this light is unaffected by any of the forces of the Earth, then it must be in a vacuum like the LIGO. If it's not, then it can be affected by.
Well, normally, so you've got ring laser gyroscopes, which are little vacuum tubes, or you've got fiber optic cables, which is basically little glass strands that the light travels through. So yeah, it is that. So
it does have a contained vacuum which will fail to bend the light.
Yeah, well, actually, Bob said it was a ring laser gyroscope, but it's not. It's a fiber optic gyroscope. They're very similar, but it uses fiber optic cables, which is what broadband stuff is transferred through, so it can travel at the speed of light.
Under the sea, everything's better when it's...
So, and as this animation showed, the only thing that can cause an interference pattern, i.e. the light traveling back out of sync, is if there is a physical movement. There literally is nothing else that can cause this interference pattern other than it registering a physical movement relative
that might
to itself.
Be true. That might end up being true, but I can't. I'm not prepared to say right now that's the only explanation. You might be right. Maybe we live on a convex rotating Earth, and this evidence does appear to support that. And
yeah,
I won't deny
why
that.
I use this.
However,
as a
there might be. There might, and somebody more knowledgeable than myself might be like, oh, why isn't he saying this? It's because I'm not as smart as every concave earther. In fact, I know I'm not. There may be a good explanation for how this works on a stationary, regardless of shape, regardless of concave, convex, regardless or flat. I'm just saying there may be a way this can be explained on a stationary surface, even a convex stationary. So shape aside, there may be a way to explain this on a stationary surface. There might not be.
I would love to hear one because
Me too.
I've got a bachelor's degree in physics, so I think I've got a pretty good understanding of the physical nature of things like light and stuff like that. I spent a long time studying that so that I would know what it is, and I know how light propagates. I understand based on the way that light works that there is nothing else, at least that I know of, or that any other physicist knows of, that could change the interference pattern and cause it to register that 15-degree drift. And what the important thing is that it's not just a drift in one direction. It registers that drift in 3 axes, which completely matches a rotating sphere.
Yes, I agree that rotating spheres are real, and so I'm going to proceed by entertaining the notion that it's impossible for any of the forces of the Earth to be interacting with that 15-degree result. I can understand why you feel that the rotating surface underneath the gyro that the gyro is on is the only explanation. I can understand why you feel that way, and certainly that evidence does support one explanation of a rotating Earth. However, I also implore the entire, shape aside, the entire stationary Earth community to address this and say, okay, well, this is obvious evidence of rotation. Period. Something's rotating. Is it gravity and the Earth together? Or is it stationary gravity with a rotating Earth? Is it a stationary Earth with a rotating gravity? Is gravity even coming into play here? So Craig doesn't think so. I think the forces of the Earth will. I just use the word gravity because that's just whatever. We'll just use that word gravity, folks. Sorry, but the forces of the Earth, the gravitational forces, is it even possible for them to affect this this gyro here? And so that's the question right there. That answer will give us our answer. And
well,
for any one person, I don't know if any one person has that answer. It's still debated in the scientific community whether or not there is an ether. And so while we still
I
don't
wouldn't
have
say
a
it's debated in the
consensus
scientific
about that.
community. The scientific
Well,
community accepts the consensus that the aether was disproven by Maxim Morley.
okay, maybe we're all right. Well, maybe we're referring to two different communities then. I come to understand that there are flaws with what we're being taught, and it doesn't mean that that any science that's used to present the heliocentric model has to be false. No, I think there's a lot of sciences that are real, that can be explained in observations that can be explained with the heliocentric model. I just don't believe that the heliocentric model is the only explanation for all these real sciences and for all these real
let me be
observations.
clear, I'm always open to being proven wrong, all right?
Me too.
I don't claim to
Me
have
too.
knowledge of absolutely everything, but I hold my positions because they are the most logical positions to hold. And when looking at evidence of something like the Sagnac effect inside an interferometric fiber optic gyroscope, it only points to one possible model being true. And the fact that it doesn't only detect that movement around its own axis, but the movement around the sun, then also demonstrates that there is something else going on other than just its own rotation around its axis. Now, I think people in the chat have been asking for this, so we're just going to play Bob being stupid for 45 seconds, okay?
Yeah, I haven't seen the chat. So.
Right.
Sorry.
So, one sec, for 45 seconds of Bob being an absolute dumbass.
If the Earth is spinning at one rotation every 24 hours, that means that every hour it has to turn 15 degrees. And if the gyroscope is mounted anywhere on Earth, it's going to drift. In today's 21st century navigation systems, they're using what's called a ring laser gyroscope. It is extremely precise. If we could simply get one of these ring laser gyroscopes, we would be able to prove once and for all that there is no rotation to the Earth. One of the people in the community actually purchased one for $20,000. But what we found is when we turned on that gyroscope, we found that we were picking up a drift. A 15 degree per hour drift.
Thanks, Bob. Thanks. I mean, he did my job for me, basically. You've gone quiet. I don't hear you anymore. Why have I lost your audio? I seem to have lost your audio.
Yeah, I turned my mic off while you were going.
So,
Just to kind of...
for me, this is one of the strongest evidence that the heliocentric model is correct, because I haven't seen another explanation for it. You know, people try and say, like Nathan Oakley and Bob, that it's electromagnetism from the heaven or whatever, but that doesn't wash because light doesn't have a charge, which means it wouldn't be affected by things like that. I've heard people try and say that it's detecting the movement of gravity or something, but again, that doesn't wash because it detects the physical movement of what it's on, as demonstrated by Wolfie moving that fiber optic gyroscope back and forwards on the globe. And it's pretty much, for me, it's a slam dunk thing. You know, I've never come across anyone that can refute this being an evidence for the heliocentric model.
Okay, I remain open. I remain with the position
so do I.
that,
Absolutely, I'm always open.
yeah, I think it's possible that there are some, and it's like I said before with the domino effect in hundreds of years in the game of telephone. If there's error introduced, you know, then if there's been some false assumptions, then it's very possible that we could be under certain misunderstandings where we think certain things aren't possible that are. And so if we assume, well, this isn't possible, and then we take that and apply it to something else and say, well, this disproves this because we know this isn't possible. If this was possible the whole time, then that means that this and this was. And so I think, like, over time, we've just kind of gotten out of control. And we end up with all these vast, crazy distances and speeds. And I just, you know, I can understand
all,
why,
like,
from our
calculated.
position of the Earth, yeah, it's all just predictability. and so you can calculate something if you just downscale it, you just downscale it, and so you've got a small heavens instead of a big heavens, and so you could still have, the relationships between certain celestial objects. They're just all the distances are just down to a level that actually makes sense.
Again, none of that really matters when you're talking about evidence like this.
But you accept evidence, at least visual evidence from the space agencies of outer space that I don't accept. And so because excuse me, and because I'll respect your position, you respect mine, and so because we have two different fundamental premises, we're both going to have two different understandings of what's possible and what's not possible, because it doesn't mean either one of us is right or wrong. I'm just making a point here, is because we have two different foundations, we're going to have two completely different offshoots. We're going to have two completely different understandings of what's possible and what's not possible. And so this is just one example. We can apply this to all different kinds of things and say, well, I know outer space is fake, so I know that news article right there is bullshit. And you might say, well, I know outer space is real, so I know that news article isn't bullshit. And so we have two completely different thought paradigms.
But the thing is, I don't need to go to NASA or anything like that. I've got a lot of friends in this community. Red's rhetoric is an excellent source of information for space stuff, because he's recorded rockets going
ISS?
up that then... Well, not just the ISS, and calculated the actual distance to the ISS and the speed and size of the ISS, but he's also done things like record rockets going into space at particular times in the day where the sun is low enough to illuminate the gases coming out the back of the rocket. And what you see is, as the rocket increases in altitude, it gets to a point where the gas coming out the back is so expanded, it shows that rocket has transitioned into a vacuum.
Because we don't have an actual altitude or position of the moon, that means that his calculations were wrong when he calculated the distance of the I remember when a couple of years ago, I remember when Reds uploaded his P900 footage of the ISS transit in front of the moon. Then the following Passover, I decided to film that bright orange moon, and I've got geese passing in front of the moon that look just like Red's rhetoric's ISS passing in front of the moon, and so that's proof.
Here's the thing: the only thing of the moon that Reds used was the known angular size.
Feet in the air.
Like, Reds didn't need to use the distance to the moon. He simply used the known angular size of the moon, and the parallax between him and his partner, his friend Astronomy Live, who were a kilometer apart. I agree. You don't need the size or the distance of the moon. However, if you have an assumed distance to the ISS that's incorrect, then you're gonna observe. But again, Reds didn't assume anything. Reds did calculations based on only his empirical evidence, and the only things he used was the known angular size of the moon, which everyone can see. They can look up and see what the angular size of the moon is. And the only other things he used apart from that were his and Astronomy Live's relative positions on the Earth.
Wouldn't he also need the known relative size of the ISS?
No, he actually calculated that based on his observations. He calculated that the ISS was a particular size based on purely the time that the ISS took to transition the known angular size of the moon and the distance apart of the parallax based on their being 1 kilometer away from each other. So the only things that he had was the measurements of the video of the ISS transiting the moon from him and Astronomy Live. Him and Astronomy Live were 1 kilometer apart, and based on that, he just did trigonometry to calculate everything from the size of the ISS, the speed of the ISS, and the altitude of the ISS. He didn't need anything else.
So you're telling me that with just two people with cameras, and the only thing they had was two cameras.
Yep.
And the known angular size of the moon.
Yes.
And they were able to figure out everything else with just that.
Yep. Let me get the video so I can.
So they didn't need any known angular size of the ISS, because how are they determining the distance of the ISS if they don't know the size of the ISS? If they're just looking at the ISS
here it is.
If you need the angular size of the moon, then if you have aside from the speeds, how can you determine the distance of the ISS based on the angular size of the moon if you don't know the angular size of the ISS?
Right, let me get the video
Which I
up so
promise
that I
you he
can
doesn't.
show you the
I
math.
promise you he has facts and figures that NASA provides him, but we
No,
don't
that's
have
the
any
thing. He
actual
did this
hard
without
evidence
anything from
of any
NASA
size of any
purpose.
ISS.
Right.
We've never seen the ISS on the ground
We
to
can knock
measure it
out
and say,
two
okay,
birds
we
with
know
one
the ISS
stone.
is this size. All we have is these angular measurements from assumed. If you're basing the distance of the ISS based on the angular size of the moon, you're gonna need the angular size of the ISS to
Right.
you can't you just don't have enough.
Why don't we just take a couple of minutes and let Reds
formulate
explain it
an
himself?
equation if you only have the angular size of the moon.
Right, hold on.
There's
Let Reds
not enough.
let Reds explain it himself.
Useful because it allows us to do a few measurements. So parts of the moon. This is called parallax.
Right, I'll go back to here.
This is called parallax.
Zetic astronomy parallax, yes.
Yeah. You know, it talks
The
about
first thing we
gravity
need
of
to
the
do is look at the sight lines between myself and Astronomy Live. You will see in this diagram that they cross at the International Space Station, and as they continue, they end up on different parts of the moon. This is called parallax. It's the exact same thing when you look at your finger with one eye, and then by switching to the other eye, your finger appears to move relative to the background. Now this is useful because it allows us to do a few measurements. So let's go ahead and find angle A in our diagram. And since angle A equals angle B, we can knock out two birds with one stone. Now the moon is a certain size in the sky. The size it appears to us here on Earth is called its angular size. Now my friend Astronomy Live measured it directly on the same night we filmed the transit. If you wish to see his calculations, his video will be linked down below. But for this video, a simple search on Google will do just fine. And according to Google, the moon is about 0.52 degrees wide as seen from Earth. With that in mind, let's overlay our two tracks together. With this, you will see that our two tracks span a certain amount of the moon. In counting the pixel diameter from Astronomy Live's footage, we find that the moon is about 962 pixels wide. The span of our two tracks from center to center is about 224 pixels wide. If we take 962 and divide it by 224, we get a ratio of 4.29 to 1. So, if we take the angular size of the moon as 0.52 degrees wide and we divide it by the value we just found, which is 4.29, that means that angle A in our diagram comes out to 0.1212 degrees. And since angle A equals angle B, that means B is also equal to 0.1212 degrees. Now that we have angle B, we now need to find our baseline. Our baseline is the distance between myself and Astronomy Live. For this measurement, we will use Google Earth. Measuring this out gives us a value of 1.11 kilometers apart. Now we have everything we need to do some basic trig and figure out how far away we were from the space station during the observation. To do this, let's cut our triangle in half along with its values, making it a right triangle. Now we just need to solve for x, which again represents how far away we were from the ISS during the transit. So let's solve for x. 0.555 kilometers divided by the tangent of 0.0606 degrees gives us a value for x of 524.73 kilometers, or 326.05 miles. But we're not done here, because with this value, we can now find what we've been looking for, which is the altitude of the ISS from the ground. Because you see, Astronomy Live was kind enough to stop his telescope only a second after the transit. This gave me an opportunity to get this measurement from the side of his telescope. At the time of the transit, the LX200 was at 53 degrees. And yes, his telescope was leveled before the transit occurred. And just like that, we have another right triangle that we can solve to get its altitude. So let's do just that. 524.73 kilometers times the sine of 53 degrees, and when we do, we get a value of 419.06 kilometers, or 260.39 miles. And yes, that is even without taking into account the curvature of the Earth. That's right, the ISS, which some people claim is a plane, is traveling at an altitude that is impossible for a plane to reach. Keep in mind that 260 miles is over 1.37 million feet, and even those rocket planes that I mentioned earlier have a max altitude of around 350,000 feet of unsustained flight, nowhere close to the 1.3 million feet of sustained flight of the International Space Station. So guys, I'm calling it here. The ISS is not a plane and is indeed in space. And if you would like to see confirmation of the size and speed of the ISS, please click the link down below to see Astronomy Live's video. With that, my name is Red.
So, using those calculations, based on the fact that they know the angular size of the moon, they know the altitude, they can therefore calculate the speed, and if they know the speed and the traversal time of the angular size of the moon, they can calculate what the size of the ISS is because they know the altitude. And that was all linked in Astronomy Live's video that went through a bit more of the maths. I will link Astronomy Live's video in and Red's video in the description of this for team.
Yeah, link that one,
so if
link
anyone
that
wants
one
to see
down
that
below.
itself. But as you can see, they didn't take
those
any
equations-
details from NASA. They literally only took the details that they had themselves.
Right.
So I mean,
So we're gonna. So we can take my footage then. We can take my footage. So I'm gonna screen share something real quick. I'm gonna go to
Okay.
my footage. Am I still screen sharing? Okay, I am
yes,
screen
you
sharing.
are. Let me just get you up on the screen. 1 second.
Yeah, take your time. I don't even have the video up yet.
So
let's
many
see, there's this
tabs
one.
open. We'll just high IQ research. There we go.
Okay. Bear with me
Okay.
a second. When this loads, the internet.
I think after this point, we will wrap it up for tonight.
Yeah, it's getting too long for one video. We can have more discussions.
Yeah,
Obviously.
absolutely. I'm
This
actually
is-
enjoying
this
these
has been
conversations.
Some of the most fruitful discussions I've had is with some of the convex earthers, where we can actually, it seems that the convex and concave earthers are the only ones that want to address any real science and
Oh
try
yeah,
to figure things
absolutely.
out.
At least you agree there's
Actually
curves.
work together. Yeah, I mean, at least we could. I mean, come on. I heard one flat earther tell me that. What did she say? I'll leave her nameless because I don't want to absolutely embarrass her. But she told me that measurements are not scientific evidence, and my draw, my draw, yeah, total facepalm. I'm like, you have to be kidding me. Measurements are not scientific evidence. Like, I'm sorry, sweetheart. We can't talk anymore. I'm sorry. We can't talk anymore. We gotta go. All right. Come on. What the heck is this doing? Oh, you know what? Why is it not in there? Where is it? Okay, here we go. Oh, I still remember. It's right at 4 minutes and 32 seconds. It's very interesting. Okay, so this footage was taken March 31st in Boston, and you guys are seeing this, right?
Yes.
Okay. Okay, so right at, I think it wasn't at 4:32, it was 4 something. A couple seconds here, you're going to see some birds. Okay, so that's a flock of geese.
Mm-hmm.
Now, we should be able to take this, one of these birds,
The important
and
thing.
we should be able to use these formulas now based on the angular size of the. We don't
you're
need
missing an
the
important
size.
thing. Like the thing about Red's observation is that he had 2 people observing from the ground that were a known distance apart.
And
So-
known distance apart, and I don't have that, right?
No, if you had another person,
That
say a
changes
kilometer
everything.
away, looking at the moon and saw those birds as well, you could then take that parallax data and do the calculations that Red did to figure out how far up the birds are and how fast the birds are going. But you don't have
Okay.
that parallax from a second observation.
Right, I don't. Right. So what I'm trying to do, I'm not trying to prove anything here. What I'm trying to do is trigger thought, and the thought that I'm trying to trigger, is that if just hypothetically, suppose I had another person 1.11 kilometers away, and they filmed this flock of geese like I just did. Mm-hmm. Then at that point, we would then be able to use the formulas that Reds provided. Yep, basic trig, and we'd be able to triangulate. We'd be able to triangulate the position of these birds. By position,
we could figure out the altitudes, we could figure out the speed, we could even figure out the size of the birds.
Right. And so all I want to point out is that these just on the footage, aside from all the math, just the observations. I just want to point out the observations that when you observe Red's footage of the ISS passing the moon, and you observe the footage of these birds passing the moon, you're going to notice that the ISS in reality, the real size of the ISS is roughly the size of a football field, mm-hmm. which is way bigger than these birds. Yeah. But you'll notice that ratio, the ratio of football field to bird, we're talking a goose that's probably at biggest 2 feet. Okay, versus the size of a football field. When you scale that, you're going to notice that something's off. When you compare the size of a football field to a bird, and then you compare the size of in the observation, the size of this bird to the ISS and Red's footage, you're going to realize, wait a minute, that's not to scale. Also, you're going to notice that the ISS is allegedly traveling at some thousands of miles per hour.
17,000 miles an hour.
Correct. It must be traveling at that 17,000 miles per hour. You're also going to notice that when you compare the speeds of the ISS and Red's footage, aside from all the math, I'm just saying based on the observation, when you look at it, the speed of the motion, the time it takes. So we have we have a angular size of the moon, right? Yeah. 0.52 or whatever it was. 0.52. So that's from one side. The diameter, the size of this moon. So when we have the ISS start to when it actually begins to pass the moon, when it goes from this point, you can see my mouse, right? When it goes from, his footage was bottom to top, actually. So it doesn't matter. When you go from the diameter, bottom to top, when it goes from here to here, or when the birds go from here to here, the time it takes, you're going to notice that the relative optical, not the actual speed. I'm just saying these birds are...
The time, what we're saying is the time it appears to take to cross the moon is similar to what the ISS had.
When you actually watch this in real time, when you watch the ISS in Red's footage, when you watch it in real time, the speed of the ISS past the moon, it is faster than the birds passing this moon. But it can't be 17,000 miles an hour compared to 30 miles an hour that the birds.
The thing is, those birds are a lot closer than the ISS.
That much of it. The ratio of speed between 17,000 miles an hour mm-hmm. and say 20 or 30 miles an hour, optically, if you just watch the raw footage of these birds past the moon, and you watch the raw footage, not slowed down, not sped up or anything, you just watch the raw 100% speed footage, you're going to notice that either these birds are flying at thousands of miles an hour or the ISS is going about 100.
Right, let me give you this thought experiment, okay? Imagine you're on a field looking straight out, and there's a car 10 meters away from you, and there's a car 100 meters away from you, all right? Now, the car in front of you that's close to you is traveling 2 or 3 miles an hour, but the car that's a lot further away is traveling 20, 30 miles an hour. They will look from your position that they're traveling the same speed because of the, something is further away. It has to travel the angular size in the same amount of time, but that means that will be traveling faster than the thing that is closer. And it's the same here. I totally understand what the birds are so much closer than the ISS is. The birds are a couple of 100 feet up traveling at 30 miles an hour. And you would be able to calculate that if you had the parallax. And that's the same, because they're a lot closer, the parallax would be a lot less. Maybe a lot more. My brain stopped working. It's nearly 3 a.m. But you'd be able to use the parallax between the footage of someone else distance away to calculate how
Yeah,
you
it
know
would be more.
how high up those birds are, and then if you know the altitude and the angular size of the moon, you can calculate the speed and even the size of the birds. So
Sure,
using
I
Red's
agree with
formulas,
that.
if you had the parallax, you'd actually get
If I had the
they're
parallax.
closer. Yeah,
Right,
but
because you could have close birds and a faraway ISS that both appear the same size because
yes,
you've got a small object closer
these
relative to a
cows are far
larger
away.
object
These
that's
cows are
further
small.
away. Right, right, and they both cows appear the same size because you have a baby cow close to you and an adult cow further away. They both appear the same size. I get you
Yeah.
totally. So I just, but optically, I just don't have any. I don't know. I just don't see how. Even using those formulas, I just don't see any proof that ISS is hundreds of miles up in the sky.
Well,
I mean,
it can only be that based
simply
on the calculations. Unless trigonometry is wrong, then, I mean, it can't be anything else. And Red's not making any assumptions because he's just going with physical observations, like the known angular size of the sky, of the moon, sorry, and the known distance that him and Astronomy Live were apart. And you know, that was literally the only things they needed to do the calculations that they did. There was nothing from NASA. There was no assumptions. It was just empirical evidence.
But I do think there, I do think there are, because you're seeing the moon. The moon is a different distance away than the ISS would be, and because we're looking through an atmosphere, which includes atmospheric magnification, so now we're looking at an atmosphere that we know is going to magnify things, and it's going to magnify different things at different rates at different distances. So what I mean by that is, let's say we're looking at over the water. Let's say Rob Skiba's magnification video. So he just uploaded another sunset.
I'm working on a Rob Skiba video at the moment because he said some incredibly stupid stuff.
Not the first time. I love you, Rob, but you know, time to wake up. Anyways, so dealing with atmospheric, get back to point. Dealing with atmospheric magnification. If you, let's say you have a footage and you're zooming in at a building, right? If one building, let's say you're zooming in at a building 1 mile away, the atmospheric magnification is going to magnify that building differently than a building that's 2 miles away, because they're two different distances. The air in between the observer, and the building is a different amount. Now it's going to be magnified differently. And so the false premise that I see here is the very angular size of the moon itself. If we're going to use everything as a constant, we know that whether we're talking about the birds or the ISS, the birds are a different distance away than the moon is, and the ISS is a different distance away than the moon is. So there's got to be a flaw with these calculations, because the angular sizes, I don't trust that the angular sizes are precise, because we know atmospheric magnification is real.
Yeah, but the thing is, it's based on the angular size that the moon appears to us.
Right, right, exactly. That's just an apparition of the moon, and because it's appearing in a different location for each person, just like the sun. It's appearing at a certain altitude and position for each viewer, which means that angular size of the moon might not mean anything, because the ISS and birds are both tangible objects.
But here's the thing, right?
Moon,
the calculations that Red's figured out, the things that he figured out, the altitude of the ISS, the speed of the ISS, the size of the ISS, those things that he calculated purely from his and Astronomy Live's observations match what we're told by NASA. He didn't get any of the information from NASA, but what he got, based purely on his empirical observations, matched what NASA tell us to be the truth.
Right.
So I mean, it's backing it up, right?
But just okay. So NASA told the truth. That doesn't prove any model.
Right. Anyway, I think that's probably a good place to stop it.
The angular size of the moon can be the angular size of the moon in both models.
Yeah, I mean, no one's disputing the angular size of the moon. We know the angular size of the moon is what it appears to us. But anyway, I think that's about time for us to stop. I mean, I think this conversation should carry on. You and team should probably talk again because there's a lot of things the team wanted to ask you, I know. I'm in the chat, guys. It's not team talking, it's me. So I do hope the team's okay. I don't know at the moment. I'm sure he'll update everybody. Team Skeptic says, prove your FTFE. Quit asking me to sprinkle MT. He says, prove your FTFE by whistling. There we go. I can whistle. He can't. Do you want to see Team Skeptic's face when he tries to whistle? It's hilarious. This is Team Skeptic's face when he tries to whistle. I know, isn't it brilliant? He's been trying to whistle for a long time. He just can't do it. But guys, I'm going to read out the super chats now, and then we're going to shut it down for tonight. On behalf of team, thank you very much for the super chats. I know it means a great deal to him. So we've got the plot hole for $5 US. Is this how a flat earther comes back to the globe Earth gradually to save face? I don't know. What I found talking to a concave earther is you're actually a lot more willing to listen to evidence than flat earthers are, which is a good thing. Schrodinger's cat 199, the poor guy, I just feel bad for him. John Rapp, everyone make sure to say hi to John Rapp in the appropriate way. The geometry is just wrong. We can see more than 180 degrees east, west, north, south, and all opposite angles. A sphere in the sky cannot be seen to extent. Do you want to respond to that, Alice? No? Okay. The Athens 619 for $5. Name of this debate, ad hoc ad nauseum. Sir for $5, you don't know that I don't have evidence, never presents evidence. I think we did get back to his evidence of the sun. So, John Rapp for $2, sorry, I missed the word, that extent. Yeah, that's okay, we know what you meant. Neko Ajic for $5, skeptic, asking why we do not get crushed against the side of the swimming pool, regardless of the size of the pool, but the depth is critical. Oh, yeah, Alice, I think that was a response to your suggestion that gravity is nothing but pressure.
Yeah, I didn't understand. Could you read off that question again?
It says, why do we not get crushed against the side of the swimming pool, regardless of the size of the pool, but the depth is critical? So I think he's asking, why is the pressure of the water not the same at the sides of the pool as of the bottom of the pool, if it's just to do with the amount that's there?
Well, that shows that these quote unquote forces that cause things to go up and down are up and down and not sideways. And so obviously because there's a gradient, so obviously pressure changes as you change with elevation. So whether you descend into water or whether you ascend into a different form of water, both are pressure systems and both will cause things to find equilibrium vertically. And so I don't know why he would be expecting things to be pressed to the side of a pool.
I think his point is that there's a downward force.
Yeah, I think everybody in the world agrees that there is a downwards force.
Well, not everyone.
I don't think there's just a... Well, I mean, I don't want to paint things with a broad brush. There's more than just different flat earthers have different views. Some say density, and other flat earthers are more wise than that, and they understand. While they still believe they live on a flat plane somehow, they still understand that the reason things go down have more to do with just density and buoyancy. Neither one of those are forces. First of all, density is a property. First of all, density is not a force. That's just silly.
No.
And buoyancy is not a force. Buoyancy is a result of force. Buoyancy is a result of forces. It's not a force. Yeah,
absolutely.
Pressure will create buoyancy. Pressure is a force. Buoyancy is not a force. So you cannot have density and buoyancy as your answer. I'm sorry, that's just not good enough.
Absolutely. Right. John Rapp for $2 Australian. A simple optical level would look above a horizon. Curtis Reynolds for $5. Sounds good. Concave Earth proven. Ha! Just kidding. German equatorial mounts, globe proven. Yeah, that equatorial mounts is a good conversation that we should definitely have. End Flat Earth for $5. There is no evidence the Earth is anything but a spherical planet. JL Warren for 199. Fight. Bob also tried to cover it up, show that. I don't have that part of the documentary available right now, but yes, Bob's exact words were, this is classified, so we don't say this. You know, if this information gets out right now, we'd be finished. Cheers, Bob. Thanks again. And math science.
Hey, I believe he used the words "spilled the beans" too. We should find that. I've got that one. Spilled the beans. Yeah, that's a good one.
And math science for just $1 with no message. Team, thanks you all for your super chats. Guys, I know not everyone is able to super chat, but the best way that you can help Team's channel and my channel is by sharing our stuff on wherever you go. Facebook, Twitter, Bebo, MySpace. Is AOL still a thing? Who knows? Share it on there anyway. Zenith, I want to say thank you very much for another civil conversation. It's a change of pace than talking with flat earthers.
Absolutely.
So yeah, I do appreciate that, but I think we will get you back to finish some more of the things that we're talking about, because there's quite a few points that got glossed over that I think we could flesh out a bit. But we're going to shut it down for tonight, guys. Thank you very much for joining. I'm sure Team appreciates it. He's busy dealing with family stuff. So thank you everyone for joining it. It means the world. And we will see you tomorrow on my channel for a debate that I have against Joey Rocha's best friend, who actually lives and works with Joey Rocha. So that should be fun. And then on Monday, I'm debating another concave earther, which should be also fun. But that's it for tonight, guys. Thank you very much for joining. Stupidity is not a right. Fight the flat earth.